Welcome to lesson 25 of this Arduino C++ course, and today we're going to be looking at serial communication. Now this is just going to be part one because it's quite a big subject, so I thought I'd break it down into 2 or 3 videos to make it easier. So moving over to the desktop, I have got 2 Unos that are connected to each other and they are speaking to each other via serial communication. So if I turn this potentiometer here, sorry if it's a bit jumpy, it's actually the connection into the breadboard of the potentiometer that's causing the problem. But you can see that I can move the potentiometer and that turns the servo on the other board. Let's just disconnect those for a moment. Now, some other items that I've got here, there is a couple of MP3 players. Now, these also require serial communication. So not only does serial communication allow us to communicate between boards, we can connect to other devices. This is a USB-C connector. Now, this one, although USB-C has lots of other little things that it can do, at its absolute basics, you can see that this connector has got a ground, a VCC, and 2 digital connections, which are actually for the signal. So we can send serial communication over USB. In fact, that's its name, Universal Serial Bus. So serial communication can be used with a lot of things. It's still used with a lot of commercial devices. So learning to communicate over serial is very, very useful. It's especially useful if you want to separate out, if you like, the item that's moving or being controlled from the controller. Now, I've just done a series on model railway control panels where everything's sort of on one board. I tend to have the control panel in one area and then the items being controlled on another board. So we'll look today at how serial can be used. Now, as well as these various items, other things that serial can be used for is Bluetooth communication. So the lessons that you learn in communicating between 2 Arduinos can then be used for your Bluetooth connections. It can also be used for RS485 and RS232 connections. So lots of different sort of formats can be used just by learning the basics of serial communication. Now, as always, the code is available over on the Digital Town website. Just click on the link below the video. As you can see, it's in the title screen. That link will take you over to the Digital Town's website, and then just scroll down through the lessons until you get to lesson 25. Where are we? 25, down there. Now, you can download the code for today's lessons. What there isn't today is a circuit diagram, because you're not going to need one. All you will need is an Uno plugged into the USB port, just as you would normally use it with the IDE, because we're going to learn some of the issues about serial communication just by communicating to and from the serial monitor. So, as today's circuit just consists of an Uno plugged into the USB socket, we're not going to spend a lot of time looking at the workbench today, because who wants to look at a board? Right. Let's start to think about how serial communication works. So I'm going to start off with a little bit of the theory of how serial communication works. We've used serial communication in most of the sketches in the previous lessons because we use Serial.print all the time to send data to the serial monitor. But today I'm going to explain a little bit more about exactly how it works. So what we're going to use to start with is the decimal number 124, which has a hex value of 7C, or a binary value of 011111100. Now, there are 2 ways that we could send this data over. One is called parallel data, and the other is called serial data. Now, with parallel data, we send the whole byte of information because there's 8 bits in a byte. So we send all of this information over at exactly the same time. Now, to do that is going to require 8 wires for the data. We're going to need a ground. We're probably going to need a VCC and 1 or 2 other connections going through that cable. Now, for those of us that are old enough, we remember the days when a lot of printers were connected to computers via parallel cables. So this method of communication was quite popular years ago. What you required was a multi-cable connector. You can see here, this one has 25 pins in it. And that means, of course, that you've got all these nice different color wires inside the cable. Now, the good side about parallel communication is obviously it was much faster in that you could send 8 bits at a time. So an entire byte was sent over in one go. The downside, as you've seen, is that the cables are pretty thick. If we just put this cable next to the bottom of my mobile phone, you can see that the idea of plugging a cable like that into your mobile phone is just not going to work. And obviously these cables were not the most flexible. So they were great for printers in their day, but now this is one of the reasons why serial communication has caught on so much. So coming back to our diagram, rather than sending everything in one go with serial communication, we send over a 0, a 0, a 1, a 1, a 1, a 1, a 1, and a 0, and we have to send them over in an order. Not just sending them over in an order, but we have to send them over in specific timed intervals so that we know how to pick them up in the specific timed intervals. Now, the next thing we come down to is a little bit of a problem with serial data. If we send all 8 bits over, we've sent a complete byte. So when the next values come through, we've got another byte. With serial communication, as I've said, we've got to send all these bits across. So we've got to count, if you like, 8 bits, 8 sort of changes to the voltage in the line. And then we send the next byte through. And this is where the problem comes. So this is the byte that we want to send. We're going to use this as the byte that was sent before. This is the byte that is being sent afterwards. And the problem that you then get is when we send this information across, how do we know where the specific byte starts and where this specific byte finishes? Because if we turn on our receiving unit and it's in the middle of a stream of data, it may start reading from here and then think that that is the byte rather than knowing where the start and the finish is. Now, if we go to the Arduino IDE, if we think back, going back to lesson 2, and we've used it in just about every other lesson, when we start the serial communication, we just tend to put in serial.begin and then the baud rate, the speed that we want the system to read at or transmit at. Now, coming back to our diagram, that tells the system how often that it needs to check the read line to see if anything has arrived. But there is something more going on with this line of code, and we'll look it up in the reference now so you can see what I mean. So in the Arduino language reference, if you come down to communications, go to serial, And then as you scroll down, you will see the information about the serial begin. So if I click on that, we have the parameters. Now, the way we usually write it is serial.begin with the speed. However, there is something here called the config. Now, this is the way that, if you like, the system communicates over serial, so it knows how the data is arriving. Now, by default, the Arduino is set to what is called serial_8N1. But there are lots of other communications. For those of you that are into your model railways, if you're using JMRI, then you need to set the serial as serial_8N2. So these are different communication protocols. And it's these protocols that when we come back to our packet of data, our byte of data, they are the protocols that help set the start and the end of the byte of data. Now, thankfully, this all takes place in the background. We don't have to worry about it. The communications protocol chips deal with all of that. However, I'm just going to show you again. This is a page. There'll be a link on the Digital Town website to this one because it's quite a useful one, fairly simple to understand. Obviously, we're showing our byte of data and it's showing the resultant waveform that would be transmitted. But the bit that I want you to take a look at is the protocol. So the protocol we're using is 8N1. Now, what this then does is it takes the 8 bits of data, bit 0 to bit 7, and it has a start bit and a stop bit. Now, obviously, these are the timings that these are being read at. That's set by our baud rate. So, but what this is basically doing is it's putting a wrapper around our bits of data. So the system goes, okay, I'm going to look for a start bit, then I'm going to have 8 bits of data, then I'm going to have a stop bit. Now, there are other forms of data that you'll see within this page. This one has another bit of data that's called the parity bit, and this works out again. There's 2 types of parity bit, an even and an odd, and this does a sort of a mathematical check to try and work out has the data transmitted correctly. So I'll leave the link to this page, but the bit that I want you to understand is that we've started off with 8 bits, but in our, if you like, our default transmission, we're actually now transmitting 10 bits for every byte that we send. Now, the reason this is important is it allows us to work out the maximum amount of data that we can send. So 9,600 baud, 9,600 bits per second, but we've got 10 bits to the byte. So we now know if we divide by 10, we can send 960 bytes per second, or we can send 480 ints per second because an integer is 2 bytes, or we can send 240 longs per second. Also, of course, if you think about an ASCII character, that is 1 byte. So again, you are limited to a transmission rate of 960 bytes per second if you are using a baud rate of 9,600. Now, when you are working on a project, if you are transmitting a lot of data, what I would say is do not go anywhere near these limits. You want to be quite a bit lower. I would sort of go 2/3 realistically maximum. So we're looking realistically at around the 700 bytes per second, because that allows for any problems that you have in the transmission, as we'll see in a bit, because it's quite easy to cause yourself some problems. So in today's lesson, we're going to look basically at some of the problems that you can come across and just some things you need to be aware of. So we're going to start off with a very simple sketch. It doesn't get much more basic than this. We've got a timer using millis. It's going to go off every 500 milliseconds, every half a second, and when it does, it's going to print serial V1. Now, as you can see, it's printing away quite happily. If I put the clock on, you can see that every half a second that is sending over that data to the serial monitor. And because we're only sending a few characters, and I'm doing it every half a second, we are nowhere near the limits of our transmission. However, there is an area that it is very easy to get caught out with, especially if you're a beginner and you're trying to send large strings. So what I'm going to look at now is what are called the serial buffers. Now, the serial buffers hold 64 bytes, and they are a ring buffer or a FIFO buffer. Now, I have put a link to a tutorial I did on ring buffers or FIFO buffers. FIFO stands for first in, first out. So if you want to know more about those, then just click on the link and it'll give you a full video on that. But let's just quickly go through the basics. So the way the buffers work, and again, there's a send and a receive, two separate buffers. They can store the 64 bytes of data. We pour our string in, so we've got send dash string dash 1234. I haven't put all 64 bytes in, the diagram gets too big. But as we put these in, it then starts to transmit each character one at a time. Now, as it sends a character, I can then add another character into the buffer. So the buffer can only hold 64 bytes at one time, and these characters are going to be transmitted about every millisecond at a baud rate of 9,600. So you could send, realistically, as we've said, 960 characters. I would be moving that down to about the 700 to be safe. So if we said it's going to be about every 1.2 milliseconds, you're going to be able to send a transmission. All we need to do is make sure that we don't try filling this buffer quicker than it can send them out, because if that happens, it causes a very interesting problem in our program. So to demonstrate the problem that you can have with buffers, I've written this sketch just to show the issue. Now, this one is going to be triggered every 1 second. In the setup, I've commented out the serial print statement. Now, the reason for this is I did not want this value to corrupt the results that I'm getting. So what's going to happen is we've got a normal timer here. Every 1 second, in this case, we are going to take the time since the baud started in microseconds, not milliseconds, microseconds, so a lot smaller value. We are then going to send a number of bytes of data to the buffer. In this case, we're going to send 10, and then we are going to serial write all of those. Now I'm using serial write rather than serial print, because serial write is literally just going to send the byte of data. There's going to be no carriage returns or anything like that with it. So we're just sending the data. And then I'm going to take the time in microseconds after all that's taken place. Once that's happened, we're going to serial print out the difference in time between the start and the finish. And then we're also going to work out what happens, if you like, how many bytes are sent, how many microseconds it takes for the byte to be transmitted. So let's get this uploaded. So the code's uploaded and you can see that it is taking 60 microseconds to send my 10 bytes. And that means obviously we're taking 6 microseconds per byte. Now that's because it's put all of that into the buffer, and because I'm not filling the buffer, it's now sending that data after I have loaded up the buffer. So let's increase that value from 10. What I've done now is I've increased the value to 30. Now, when we come down to the loop, it's now sending that data across, and the values that I'm now getting are 172, 175 sometimes, and 5. So the previous values were 60 and 6. So instead of it taking 6 microseconds, it's taking on average 5 microseconds per character. Now that's because of some of the rounding off of some of the overheads. But the reason this is going so quick, this doesn't mean that that data is being transmitted that fast. It just means I can load it in the buffer that fast into that receipt send buffer, because the buffer is not full. Now what I'm going to do, we're going to change this value to 60. Now once again, as I've changed it, I'm still getting a value of 344, but that's working out at 5 microseconds per character. And that's because by the time I send the next data to the buffer has already been emptied. Now, if you remember, we've got a 64 byte buffer and we're currently sending 60 bytes. Now let's take a look what happens if we send more bytes. What I've done now is I've increased the value to 80. Now what I want you to do is notice the values here. You see how now the time per byte to be sent across has jumped from 5 to 195. Now the reason for that is that I have filled the buffer, and now the system has to wait for a space to be available before it can put the next byte into the buffer. So going back to our diagram, I've completely filled the buffer. I've now got to wait for a space before the next character can be put into the buffer. Now the problem is that now, rather than it being a high-speed dump into the buffer, I've now got to wait for that space to come up, which, as we know, to send a byte is going to take 1 millisecond. So for every character that I have not got space for in the buffer, I've now got to wait 1 millisecond. And that's why all of a sudden the speed has dropped from 5 microseconds, and now we're averaging 195. Now, if I increase this even more, let's put it up to 200. Now look at it, we're now up to 700, and the more the buffer gets overflowed, the larger that number will become, and it will eventually get close to the 1000 or 1 millisecond. Now at this point, a lot of people will sort of say, well, the solution is obvious. You need to increase the baud rate. Well, I'm going to increase the baud rate. I'm going to set 115,200 and let's upload the code. As you can see, the time has reduced, but it's still at sort of 57. Now, when I was at a baud rate of 9,600 and I wasn't overflowing the buffer, that value had dropped to 6. So that is a 10-fold increase, even though I have increased the baud rate dramatically. Now I've just increased that value to 400, and as you can see, we're now at 71. So it's just one of those things to be aware of. It's not just the speed that the data transmits across, but also the amount of data that you are putting into the hopper, into that buffer in one go. Now what I've done is I've reset the baud rate to 9600 and I'm going to send 200 characters across. So now we're getting a value of, let's just stop that scrolling, getting a value of 140420 and 702 microseconds per character. The issue is not so much this value here, the issue is on this line, because that is the total amount of time that it is taking that for loop to finish. Now that means that that is taking 0.1404 of a second, 140 milliseconds. Now the issue that that has is that then can very quickly become a blocking code on your program. It's quite weird. I spend ages telling people don't stick delay in your code, but if you start to overload the buffer, the Arduino literally forces itself to go into a delay until it can feed all the characters into the buffer. So if you've got something that is timing critical, you need to think very carefully about the data that you are sending over to the buffer. And that's particularly important if you are trying to send long strings of text. So now that we've seen some of the issues with the send buffer and how it's possible to overflow that buffer, I'm now going to show you some issues that you can come across with the receive buffer that can really cause some sort of head scratching when it starts to appear. Now, the difference is when we are sending the data, we can literally throw as much data into that buffer as we want, preferably less than 64 bytes. With the receive buffer, it can only receive 64 bytes before it's full. And so what's important for us is we've got to be retrieving the data from this buffer so the next data can go in. Now, in previous sketches, we've constantly serial printed to the serial monitor. This time we're going to do something the opposite. We're going to send data from the serial monitor to the Arduino. Now, again, I've got this timer running. It's going to be running every 1 second. The baud rate is 9600, so it's not particularly fast. And we have a variable here that's going to store the incoming byte. So let's have a quick look at the code, because we've not read incoming data before. It's very simple. We have an if statement. This Serial.available tells us how many bytes are waiting in that buffer to be read. So from our point of view, if it's greater than 0, I want to read the next byte. And then all I'm going to do is print out that byte. Now I'm printing it out and I'm going to write it out. The difference is one's going to give the ASCII character, the other is going to give the numeric value that is sent. So I'm going to start off first with a numeric value. I'm going to type in 23, press return. And what we now see is a value of, we've got the 2 and the 3. That gives a ASCII 50 and 51. And then you'll notice we've got an ASCII value of 13 and an ASCII value of 10 with nothing showing. Now that's because I have NL and CR set. So it's going to send a carriage return and sort of an end of line. Now, if I remove those and type 23 again, this time I only get the 2 and the 3 and the basically the ASCII values. So that's not a problem. That's come through very nicely. let's put, a reasonably long line of text in. We'll put our carriage returns in so that we can see them, and let's press return. And once again, as I scroll down, you can see that that has all come through very, very successfully. Now, just to stress the point a little bit more, I'm going to put in this very long string and press return. There we go. Everything has come through correctly. So you can see that I can't actually overload at the moment the incoming buffer because I'm reading this data so quickly that the buffer never gets full. So for this final sketch, I'm going to show you how to overload the buffer. And this is why I keep going on about don't use delay in your code. So we're just going to start the serial communication, baud rate 9600, serial print out the name of the sketch. We've still got our incoming byte. Now to speed up the reading of the data, I've put a while loop in. So while there is data available, it will spin round this while loop as fast as possible, sucking out all the data out of the buffer. However, you will notice that I've got a delay in there. Now that means that we're going to wait 1 second, then we're going to go through this loop, then we're going to wait 1 second, and we're going to go through the loop again. Now, when I ran that previous sketch, it didn't matter how long a line of characters I put in, they just printed out. Now, as you can see, those have all come through. But what I'm going to do now is I'm going to put in a long line of characters that worked perfectly well under the old system. I'm just going to clear the output so you can see what comes out. Now notice this is the alphabet lowercase 0 to 9, alphabet uppercase 0 to 9. Let's send it. Now, if you noticed when it started, you saw the ABC come through very quickly, and then there was delay. Now, that was because it was just coming out of the previous cycle. But what I want you to notice is where the string ended. The string that I put in finishes in a 9. This has only finished at the 3, so this bit of the string is missing. And that's because during the delay period, data was still being transmitted in towards the buffer. The buffer no longer had any space for it. It can't send the data back, so it just loses it. So if you overload your inbound buffer, your read buffer, the danger is that not that your code will get a block from the waiting period. What you're actually going to lose is your data that you are transmitting. And so if we were sending this twice, let's just do that, just clear it again. So I'm going to send that string, and I'm going to paste it in again, and I'm going to send it again. Now, what would then happen if I was reading this data? We can see that we get to the uppercase version, and we get to X, Y, Z, 0, and then I jump immediately to A. Now, if I'm expecting this data to be in a specific order or a specific type, that is going to cause me a big problem because there are 8 bytes of data that are missing due to that delay. And this is why things like delay can cause you so many issues. And it means that when you are sending data, when you are receiving the data, you need to make sure that you are clearing the buffer as quickly as possible, even if you then have to put it in your own buffer. So I'm going to end this lesson here just to prevent it from becoming too long a lesson. But the important points for you to take away today is that if you do not clear the buffer, or if you send too much data to a buffer, that is going to cause problems within your code. And so you need to make sure that you are clearing the incoming data as quickly as possible. And also when you're sending data, that you are sending it in the correct rate, that you're not overloading, if you like, your send buffer. Now, in the next video, we're going to go back to the communication between those two UNOs, and we're going to start with basic communication, and then we will start to work up to how we write code to make sure that all our data has arrived correctly and that we know if there is an error in the data. So that'll take place in the next lesson. So I hope you've enjoyed that and it's been useful. Again, there are those links to the FIFO buffer and to that page on the formatting of packets if you want to learn a little bit more about that. It's not essential, but sometimes people want to learn a little bit more. And if you've got any questions, please put them in the comments below the video and I'll try and include them in the next part. So thanks for watching. See you in the next video. Bye for now.